So here on the blog that has links and stuff, we've got a presentation here, a slide presentation that I'm going to use to go through the content for today. We're going to spend a little bit of time in VBA, but not very much at all. It's really mostly conceptual today. And I'm going to kind of fast forward here to the very end. This won't make a whole lot of sense to you now until we get there. But of all this stuff that we're going to talk about today, this is kind of the table of stuff that I think you'll want to be pretty familiar with for the midterm examination. So if you're thinking I got to take some notes while we're going along here, in terms of what you need to know for evaluation here, I've given you a slide on the end. Feel free to take notes if you want to on the other stuff that we cover. I don't feel like you've got to memorize everything here. So what I really want you to do for today's lecture is just kind of focus on trying to just kind of understand this at a high level with me. One of the most important and basic fundamental concepts in any programming environment is the idea of a variable. And I'm actually kind of surprised that, even in students that are in, major in my department in information systems, they can get pretty far into it and you're pretty expert at using variables without ever really understanding what they are. We tend to think about them in terms of some kind of a metaphor, like it's a box with a name on it that you can put a value in. But I want you to understand what a variable is because it's fundamental to what we're going to be doing kind of throughout the rest of the semester in programming. So in the physical hardware of the computer, there is just one place where I can store a value and let it sit around for a little while and then call it back in and say, you know what was that value? We need to do something with it. What was that value? And what is the part of the physical hardware that lets me store a value? It's volatile. So if I lose power to the computer, it will go away. So I'm not talking about like the hard disk because that's kind of more stable storage. But what's this thing called? Random access memory. Yeah, it's like a chip like this. And so everything that we manipulate in VBA, anytime we're going to store a value, it's going to be stored somewhere into memory. Now, eventually we might say, well, we got to do something more with it to save those values after the computer shuts down. We'll typically write that into the worksheet somewhere and then save the worksheet, and that'll write it out to disk. But if we're just going to say we've got a value, maybe we've taken in something from the user or we need to hold it around because we're going to use it later, that's going to happen in memory. Now, the way that we access this, back in the early days of computing, it was a lot harder than it is now because we're going to think of, in a chip like this, it's got just kind of lots of places where you can put ones and zeros, on and off switches. That's kind of the foundation of everything that we're doing here. And so we can kind of think of that vast array of memory that we have there in the computer as a sequence of ones and zeros. That logically, that's what it is that we can refer to. We can say, you know what, we're going to change some of those to something different and be able to read them back. By the way, how many like megabytes or gigabytes of memory do you have in your computers? Anyone know? You have 256 gigabytes of memory. That's probably storage. Yeah. That'd be great. I'd love to have that. And they actually have computers with that, but you don't carry those around yet. They're like, like cloud servers and stuff. Yeah. Do you know what you got? Yeah, 16 is pretty common today. Is 16 gigabytes a lot of memory? You probably don't have any idea what that could really hold. I'm going to tell you what that can hold. That can hold 16,000 copies of the Book of Mormon. So if you're just to take the full text of the Book of Mormon, you could put that 16,000 times in memory in that computer that you're holding. That would be like taking the little blue Book of Mormon, that missionary Book of Mormon. If you stack that up, it would be higher than the Kimball Tower here on campus. I mean, it's a tremendous amount of data that you have access to there. And we'll do all kinds of things. I'll put music and videos and programs and such. But ultimately, it all comes down here to ones and zeros. So instead of having to actually think about specific ones and zeros there, we're going to use this notion of a variable to organize in our minds and in our programming how we're dealing with that memory. So, so this is what a variable is. So it is a location in memory that has a name. That's kind of the important characteristic. It's a named location in memory where a value of a particular data type can be stored and retrieved. So the idea here is that to be able to store it anywhere, it's got to be somehow mapped into a set of ones and zeros. And that whole kind of vast array of 16 gigabytes of RAM that you've got there, each one of those little ones and zeros has its own address. like a location, we could say, I want to go look at a particular 1 or 0 in memory. There's an address that points at every single one of those. And so a variable then is one of those locations in memory that we think of as a name. We don't really care exactly. What we're going to say is, listen, we're going to say to the operating system, I need some memory to hold a number. Like maybe I've just recorded like how many, let's say, you know, we're going to be, I don't know, a number, a salary. I've just you know, taken in a salary and need to hold it somewhere. So I need a few bytes of memory to be able to store that value. Do I care where that is? Like exactly where that is in memory? I don't care, as long as whenever I say that's the value I need, I get that value back and I can refer to that location. And so I'm going to ask the operating system, hey, give me some memory. And the operating system is going to say, all right, here's the memory. It's now allocated to you, VBA, or it's allocated to you, Excel. It probably sees VBA as part of Excel, the operating system does. And it's going to say, listen, if someone else tries to access that memory that I've given to you, the operating system's job to kind of prevent it from doing that. It's kind of a, you know, in the realm of malicious software to be able to kind of look and see what some other program has stored in memory. And so it's a real no-no for one program to try to access memory that wasn't given to it by the operating system. In fact, in the early days of Windows, it would happen by accident pretty often, and Windows would just like terminate the program. If your program tried to access data that didn't belong to you, it was called a general protection fault, and whatever you were doing was just, it was just dead. So the point is the operating system kind of manages who has access to that particular location of data. Now, even though we've got little bits, 1s and 0s that we're working with, the lowest level that we're going to refer to memory is going to be a set of 8 bits at a time, and that's referred to as a byte. So you know, if we got the urge to say in VBA, I really want to look at that particular bit and see what that bit is, you might be able to infer what that bit is, but you can't look at a bit and read it individually. So the smallest unit of memory that we can look at is going to be a byte, right? And this is where we get to the terms that you're familiar with, like megabyte or gigabyte, is because you've got a byte, and then if you've got 1024 of those, that's a kilobyte. 1024 kilobytes is a megabyte. 1024 megabytes is a gigabyte. It goes up from there. So, but that's the unit of measure that we're already used to working with. And so we're going to be thinking about how these things are stored in memory in terms of these bytes. Now, so let's suppose we have 1 byte here, and then each byte, so we look at this byte, each bit in this byte, how we're going to store like a value in here is we're going to say each one of those has like a numeric value. So I'll say over here, the one at the far right, that's the 1 bit. And you know, the next one over is the 2 bit. So if I just plug like a 1 into there, then I've stored the number 1. This is how I would store the number 1. This would be how I'd store the number 2. It says I have 1, 2. So I've got 1s and 0s to work with. It's binary notation, right? And so I can put in any one of those squares, I can put either a 1 or a 0, kind of indicate what I want. So what's it going to look like to store the value 3? To store a 3 is going to be 6. Oh yeah, 0, 0, 0, 0, 0, and then 1, 1. Very good. Whoops. So there's 2. In fact, when we get here to this here, we look at that. And if we just look at that and didn't really understand what we're talking about, you might think of that as 10, but this kind of leads to this kind of an old joke in programming. You can see it on t-shirts here, right? There are that number of types of people in the world, those who understand binary and those who don't. How would you actually read that? There are, yeah, 2 types of people in the world, those who understand binary and those who don't. I saw another shirt. I couldn't find a picture of it for the slideshow, but I found another shirt that was like this. There are, 10 types of people in the world, those who understand binary and those who have friends, I don't know. So 3 then is just, yeah, just what you said. So I've got 2 1s. So I've got 1 2 and 1 1. So we can go, 4 and what's that? Yeah, 65. It's just, you just take the, if the bit, it's like a sum, what is it? Like sum product, if you're kind of thinking of it in terms of Excel. You just multiply the number above it times either the 1 or the 0 and then add that up. And then you've got 65. How about this one? It's always amazing to me that someone can get there so fast. What did he do? He said 128 plus 64 plus 32 plus 16. You did that so fast. You probably used a shortcut to get there. What was it? Oh, you remembered it. Oh, you remembered it. What's the next number in the pattern? 1, 2, 4, 8, 16, 64, 128. What's the next one? 256, right? And so if I was to go to 256, it would be a 1 in that bit and everything else would clear out. So this is just 1 less than what the next in the pattern would be. So that's 255. Oh, okay. Am I going to ask you to ever do something on an exam where it's like, here's binary notation, what does it mean? And the answer is no. This is not going to really help you, like being able to map, this isn't going to help you program better, but understanding where all this stuff about memory and variables originates is going to be helpful, I think. Okay, so so the range then, what's the valid range that I could store in memory with 1 byte? So the lowest value I could store is 0. And the highest I could store is 255. So that's the range, 0 to 255, or 256 different values. Okay, so let's say I've got 2 bytes, right? Twice as much memory, so I should be able to go twice as big, right? No, not twice as big. What? Yeah, way more than twice as big, because each time I add 1 bit, I double the capacity. And so this now gets a lot bigger. So 256 is now there. I've gone past, kind of past the edge of where I could go before with the 1 in the 256. Boy, what would that be? My guess is from the last time I did this presentation, that's probably 1,000. Yeah, so 512 plus 256 plus all these others, and that gets us to 1,000. Okay, let's see. I probably should be, if I'm going to point, I probably should point using the screen so folks on the recording can see it. Let's see. Laser pointer. All right, so this then introduces us to our first data type. So remember, the definition of a variable, it's a name, it's a location in memory with a name, where a value can be stored, or a value of a specific type can be stored. And so that idea of the type of value that we're storing is really important, because ultimately everything gets stored as a 1 or a 0. And it's only by understanding what type the variable is that VBA can figure out what to do with all those 1s and 0s. Like, is it letters? Is it a number? Is it a date? Is it, something else? So the type then is really important. So here's our first type. And we're going to get familiar with several of the data types in VBA here. So the first one is byte. As you might guess, the name of it is byte, and it takes up exactly 1 byte of memory. And so if I'm going to put a variable into memory, I closed Excel. If I'm going to put a variable into I'm going to put a value into a variable of type byte, what is the range that it can hold? Right, and it's the same range we talked about just moments ago, and that is is from 0 to 255. So I'm just going to go ahead and open up my Excel environment. So developer, Visual Basic, and I'm going to insert a module. Feel free to do this along with me today, but you might be just as good off to kind of sit back and watch and kind of think about what I'm doing. But if you want to do it along with me, you certainly can. So SOB, School of Business, SUB, variables. Okay, so here's how I make the instruction in VBA to ask the operating system to give me some memory. I say the keyword dim, D-I-M. Dim it's actually just an abbreviation for dimension. I'm saying I want a particular size of memory here. So dim, and let's just dim a variable named X. Variable names can be any combination of letters, numbers, and the underscore character has to start with a letter. So here's dim X, and then I'll give it data type by saying as, and then I'll give it the type. So in this case, we're going to do byte. Okay, so now I'm going to put a value into this. I'm going to say X equals 100. Now, this is not a statement of equality. This is an assignment statement. This says take whatever's on the right hand of the equal sign and put it into whatever's on the left hand of the equal sign. So I've declared this variable that when this executes, or when this is processed, VBA will say to the operating system, hey, I need some memory. And the operating system's like, well, how much do you want? And VBA is like, I just need 1 byte. And it says, great, I'm going to allocate this byte to you. It's yours to do with what you want with it. Then the operating system gives the address back to VBA, and then VBA behind the scenes is going to keep track of that address, knows exactly where it is, and it's going to let me think of it by this name. So I never have to deal with the address. I'm going to use the name as like a nickname for that location in memory, for that address in memory. So when I say X equals that, I'm saying the location in memory that has the address that you're keeping track of for me with this name, we want to store this value in there. So then I could like print it. So just put it into like A1. So range, I'll do active cell, ACDIVE. Okay, so we're seeing something a little bit reminiscent of what we talked about last time. We talked about, in fact, let's just take a minute and review that. We got introduced to kind of 3 terms that are going to be really important to us, and kind of 2 of them, we got an example of 2 of them up here. So what were those terms? What is this? This is, in general, this is an referring, it's an object, right? So this is an object, it's a thing that I can manipulate in code. And so it's going to be evaluate to whichever cell happens to be active when the line of code runs. The dot then says this is going to either be a property or a method. Which one is this? It's a property. Yeah, it's just a value that that object is going to kind of hold. It's going to describe something about the way the object is. So I'm allocating this memory. I'm putting the value 100 at that location in memory. I'm writing into it. Now I'm going to be reading out of that location in memory and putting that into the property of the object identified here. So when I run this, what should I expect to see? Yeah, 100 should go into the value of whatever cell happens to be active at the time. So I'll go ahead and run that, and that's what it does. That's fantastic. Make a different one active, run it again, and there we go. But let's kind of focus now on the range. So let's do this. Let me, instead of doing 100, let me do 255. That should work just fine. But now let me try to go to 256. That's outside the range of what it's allowed, right? So at 255, I've got, right, that's all full of ones. Do I actually have that showing here? Maybe not. That's all full of ones at 255. There's not room for any more ones in there. Like the container that's holding those ones is full. What would happen if you had a container that was completely full and you tried to put something else into it? It would overflow. That's exactly what it would do. And so by trying to put a little more than will fit into here, that's going to be an error. And the error is actually overflow. So it's error number 6. There's like hundreds and hundreds of different error numbers you can get. This is a pretty early one, number 6. I don't know I've ever seen one lower than 6. I don't know how to make those errors. But this one just says, yeah, it says, listen, what you're trying to do is put more into there that would fit, that would overflow. And so it says it's not allowed. It prevents it from happening. So I'm going to go back here and put it to 0, the lower boundary. That should work just fine. Make sure we can see it. I'll run that. That puts the 0 in here just fine. But now let's try to do this. Oof. Now, in a sense, what we've got here is we've got this all full up with zeros, and now we're trying to go even lower. What's it going to do now? Going to underflow now if we do that? What do you think it's going to say? It's still going to be overflow. And overflow just means you tried to put something into memory that just didn't fit. So we'll run that again. We'll see that's going to overflow as well. You get the same message, overflow. Overflow, I can tell you, until you learn this, it would be like, I have no idea what that means, right? Like my code is bad somehow, but what does that message mean? It's a terrible message. It just says overflow. Would it be that hard to have said, you tried to put something into a variable that wouldn't fit? Why they don't do that, I don't know. But that's what that means. All right, questions on this data type? All right, so if we have 2 bytes, we have the data type that allows us to do 2 bytes is called integer. Integer, let's kind of look at allocating an integer, what happens here. So that, in fact, we'll just kind of look at memory right here. So that particular one in my kind of vast array of memory has an address. We typically think of addresses in hexadecimal notation. So hexadecimal is base 16, so it's 0 through 9 are your characters, and then A through F. Just kind of a different way to, we won't worry about doing with base 16. But we can also think of it in base 10. But the point is, there's a unique address for that particular location. Like the next one over is just like the next one up. So I think about this as a decimal. It's all exactly the same, but that's just the next, here it ends in 48. That one goes to 49. This one ends in 0. That goes to 1. So it's just counting up to the next one. Each one of those locations has or each one of those bits in memory has its own location. So when I say dim x as integer, then VBA says to the operating system, I need 2 bytes of RAM. And I've got, can you see the gray? Yeah, so some of these have a gray background. Some of them have just a blue background. So the gray background is indicating that's already in use. That is memory that is that memory that the operating system has allocated to something. It may be allocated to VBA. It may be allocated to some other program, but it's not available. So I can't just make a variable right on top of that. So when we say dim x as integer, we're saying operating system, I need 2 bytes of memory. And the operating system is going to find somewhere 2 bytes, two sequential bytes. So 16 bits all right next to each other that aren't being used. And it's going to say, great, it's got an address, and it will pass that address back, and VBA is going to keep track of that address and going to bind it to that variable name for me. So now, it's that kind of what VBA keeps track of is that we say, it is the variable X, it starts here, and it's the next 16 bits or the next 2 bytes. Okay, questions? Go ahead. Yeah, so the question is, how does this address determine, and you're exactly right. The very first bit is bit number 1. The next one's bit number 2, and just counts up to 16 megabytes, however many you have in there. It's a lot. There's a whole lot of them. And by the way, you've heard the difference you've heard that you have a 64-bit operating system. How many just say I've heard that term before? 64-bit operating system. And the one that it replaced was a 32-bit operating system. Do you know what the difference in that is? I mean, what's the difference between 32-bit and 64-bit operating system? So so it gets with a bus, but the term comes from how much memory you can address. So in a 64-bit operating system, the memory addresses will be 64 bits long, meaning you can address as much memory as you could with however big of a number you can make in 64 bits. It's a big number. 32-bit operating system can only address 4 gigabytes of RAM. So 32-bit operating system, if you had more than 4 gigabytes of RAM in your machine, you're running a 32-bit operating system, the rest of that memory is unused because the operating system doesn't have a memory addressing scheme big enough to be able to refer to it. So it's being able to, how much memory it can handle is where the term comes from, whether it's 32-bit or 32-bit, 64-bit. When I started, it was 8-bit. My first operating system was an 8-bit operating system. So exciting. Okay, so, and if we look here, right, we could figure out what number is being represented here. So I know that it's going to be an odd number because that's a 1. So it's got a 1, it's got no 2, no 4, it's got an 8, it's got a 16. I could just add those up, and that would be the number that is stored there. Other questions? Okay, well, so far we talked about byte, and it can handle 0 to 255, only a positive number. So the question is, how are we going to be able to handle a negative number? And this then is going to show up why the type is so important. So what VBA does is it's going to store like an absolute value of a number, but when it reads it, it says, oh, this is an integer value. Integers can have negative numbers. Byte is only positive, but integer can have negative values. So it's going to store some absolute value in there, and then it's going to say, all right, well, when I read this out, read what that number is, and then add it on to an initial starting place. And it's going to be a negative number that it starts counting from. So in this case, I have 1,000 kind of stored here in these 2 bytes. And because this is an integer type, when VBA reads that 1,000 out, it doesn't just say, hey, your value is 1,000. It says, no. We stored 1,000, but this is an integer type. And so we're going to start by going to the lower end of this boundary. And we're going to say, we'll take negative 32,768. We'll add the value that's stored in memory, 1,000, And the actual value that's represented here then, when I bring it into VBA, is going to be negative 31,768. So there's no negative sign. You have only ones and zeros in memory. And so the way that we get to negatives is we go, based on the type, I'll take the number that I have there and then add it to an initial starting value that's somewhere usually pretty low. Okay, so here then is 32,767 represented in memory. So what value is that? Like -1. Like everything full up with ones except for that very first bit ends up being -1. So that's going to be 3,768. What is that? That's the representation of 0. So the fact that this one here changes as soon as you stop being negative and go to 0 and then positive, when this is a 1 here, this very first bit in a variable is sometimes referred to as the sign bit, because you can tell what the sign is by looking at that bit. Now, we can't actually look at a bit in VBA, so kind of going to the underlying idea. So if you ever heard the term sign bit, that's what it means. It's the bit that indicates, that tells you could look at it and know what sign the number is. So here's 33,768 represented here, and it's then starts there and gets us to 1,000. So what's the difference between 1,000 and negative? Oh, never mind. Probably never mind. That's more than we want to get into. So so that's fundamentally how it's stored. We're kind of going into kind of low detail here, but we won't do this for all the data types. You'll get started here. Questions? Full up then is as big as it can go. And so we can see 32,767 is the highest it can go. So the effective range for integer is going to take 2 bytes, and it's going to be that lowest value up to the highest value. So plus or minus 32,767 or so. Now, am I going to expect you to know this range on the midterm? I am, but not this precisely. Like, you know what? If plus or minus 30,000, you'll get the feeling. The reason it's important to know the size of these variables and what their range is, because you're thinking, listen, if I've got to be able to store some data, I got to think about, I'm making this variable. What is that, how much data is going to have to go in here eventually? So I might use some test values, but how big is it going to go? Could it go bigger than 30,000? Well, technically, could it go bigger than 32,767? If the answer is yes, that's the wrong data type to use. Okay, so kind of getting good at programming with VBA, part of it is understanding what the limitations are of the different data types. And so that's why I'm going to ask you to have some sense about what the range of these are. So how much memory does it use, and how much what the range is. So so we've talked about 2 integer types so far. Byte is the first one. Integer is the second one. They both hold only integers. There's another integer type called long integer. It takes 4 bytes of RAM, and its range is plus or minus 2 billion. So that's what you have. In 64-bit operating systems, 64-bit versions of Excel, there's actually another one, because I think, wow, the numbers could get even bigger. And yeah, you want to know what it's called? I'm not going to ever test you on it or anything. So it's bigger than long. Like when they made the language, that long was as much as you would ever need. And then it's like, oh no, we need something bigger. So what did they call it? Like extra long or longer. It's actually called long. It's a long, it's not a normal long, which is not what this is. It's a long. So yeah, in fact, right, you could. Dim X as long. So long will now handle negative. So long, so that will work. Now, if I run that, but the point is it can go long. There's another data type as well, and that works as well. Okay. All right, so those are the integer types I want you to be familiar with, just byte, integer, long. Now, but what are we going to do with a decimal value? Oh, so far we just talked about integers. So our first option is to use what's referred to as a fixed point number. And so the first option is to say, listen, what we'll take is go ahead and store the integer value the same way we've been storing these integers, but we're just going to know that there's always 4 decimal places of precision kind of implicit in that number. So read the number, divide it by 10,000 to shift the decimal place over from no digits past the decimal to 4 digits past the decimal, and that would be it. So if I only had 2 bytes and I was using this kind of fixed number scheme, I'm storing 65,535. read that out, and it says the real number here is 6.5535. So again, we're storing it exactly the same way, a series of ones and zeros. It's a base number that's getting stored, but then because this is a fixed point number, we just know, we always have to shift the decimal point over. So smaller number and so forth. So currency is the only fixed character type in VBA. I'm sorry, fixed point number or fixed point variable type in VBA. It takes 8 bytes every time you use a currency variable, and it's roughly plus or minus 922 billion, and that's precise to 4 decimals. What would happen if I tried to store something that was more precise than 4 decimals? Let's just take a look. So let's make X as currency. Right, this should work just fine. Play that. Oh, interesting. When it's a currency, it gives a different formatting when it goes in. That's fun. But now let's put in 1.3333. That should go okay. Now that's just I told you wrong about the currency. I'm certain that currency is significant to 4 decimal places. Interesting. Let me put in 5555. Wow, it's only significant to 2. There may be an error here. That's what I thought at first, but you can see the raw value that's in there has been rounded. So the point is, whether it's 4 or 2, it's behaving the same. And when I try to put something in that won't fit, then it will round. So it can take 1.55, okay. But if I try to put in something larger, 1.551, it's going to round that off. It's going to round it somewhere. So 554 should round to 555, and 555 should round to 556. So it's just rounding it. That's a really good question. Let's find out. I'm going to go ahead and stop right here. We're going to have a whole lesson that talks about different techniques for debugging and error handling. But let's view the thing called the immediate window. This may be showing for you already. I'm going to bring it to the top because it'll be easier for you to see up here. This is just a place that I can send values out while I'm in my debugging environment to run here. So let me just go ahead and kind of run to there. So at this point, we've stopped the code. This is still in memory. I can come up here and say, I want to print X. And yeah, it does. That's so interesting. It does have all 4 digits of precision here. Right, let's just do a print. If I say debug.print, it will print it out there to the immediate window. Oh, debug.print X. And if I try to add 1 more 5 on it, it won't take it. But in this case, it's actually, so over here, Excel is rounding it. VBA is handling it as truncation. I am not sure the mechanism that's happening that's limiting this to 2 digits. Anyway, but over here in VBA, it does have the 4 digits that we're talking about. If I try to put in 5559, I think it's going to truncate it. Oh no, it rounds that one. Wow. 5555. Leaves at 4 5s, but if I go to 5556, it rounds it up. So it doesn't round up at 0.5. That's really weird. Anyway. So data type, currency, 8 bytes, plus or minus 2 billion with 4 decimal points of precision. Okay, so the second way that we can do it is instead of having just an inferred number of decimal points that's always going to be stored to that precision, is we could say, listen, we're going to take part of the memory that we've allocated for this variable, and we're going to use it to store the integer number the way we do all of our others, but we're going to reserve part of it to say, wait a minute, that part is going to tell us where the decimal point is. So here, what we're saying is that this part here is not part of how we know what the digits are we're dealing with. All this one does is it tells us where does the decimal point go. So now I've restricted how big of a number I can do, because instead of my highest one over here being 32,000, my highest one over here is now 2,000. My highest bit is worth 2,000, but now I can give it some decimal points. So in this case, I'm saying there are no digits past the decimal point. So this has stored 3,574, and that's what it is. But now, if I give it one decimal point, it's the same digits, but I'm saying there's one of the digits is past the decimal point. 2 of the digits is past the decimal point. 3 of the digits is past the decimal point. If I fill this all up with ones, then I've pushed that out 15 digits. So even though I can still move that decimal point over, it just has to be a bunch of leading zeros. So this is what's referred to as a floating point number. And it's called that because you're storing an integer, a set of digits, and then the point floats depending on where the other part of memory says it goes. You've heard that term before, floating point number, with respect to computing. That's what this is. Okay, so the data types that we have of these floating point numbers, the first one is called single, and it's short for single precision floating point number. So the data type is single. So if we're declaring a variable of that type, instead of currency, now we can say single, S-I-N-G-L-E. Single has 8 significant digits, or is it 7? 7 or 8 significant digits. And I've got 1, 2, 3, 4, 5, 6 here. So it should be able to show that just fine. So I'll run that, and we've got all of those digits now. You go ahead and add a few more in, and we're going to see that it can't show them all because it's limited to 1, 2, 3, 4, 5, 6, 7. So you get 7 significant digits, and then from there it's going to round. I can do really big numbers. Go ahead, question?
So in that case, why didn't it give you an overflow?
So good question. Why didn't this give me an overflow? And the answer is that in this case, and this is one of the things that some people who are experienced programmers hate about VBA. The philosophy of the language of VBA when they were creating the language was, we want to try to see if we can figure out what the user is really trying to do. And even if they haven't told us that, we're going to kind of guess at what they want. Instead of failing when you try to put a number that's in too big and just having the code stop and say, sorry, you can't do that, I'm going to say, well, we can get pretty close. Let's do the best we can and move on. And so that's the reason this doesn't show up with an overflow. Say, well, rather than overflow here, we're going to round. Question? So yeah, so the question is one of these bits reserved as a sign? And the answer is, I'm not that sure about exactly how this is implemented. So I couldn't tell you how that is. So, but let's put this, let's try to go fewer significant digits, but really precise. Let's see what that does for us. Yeah, so that's doing it as well, but you can see now it's kicked over to scientific notation. So it's 1.57 and then move the decimal point over, but it really is representing that number. It's not storing this, it's storing like the real number that's represented by that scientific notation. Questions? So your range for single is big. The range is huge. I don't even know how to say that number. But you only have a certain amount of significant digits. So you got 7 significant digits, and it's a big number. So the difference between single precision floating point number and double precision floating point number is that double has twice as much memory, and the range is absurd for how big numbers you can do here. But now you've got 15 significant digits. So it's not that much more precise. It's twice as precise, but now you can do huge, huge, huge numbers as long as you're not trying to be that precise. So for both single and double, what are you going to think about? You're going to think these can hold really big or really small numbers. The only difference then really is that I'm going to ask you to really understand and think about is how precise can these be? And the actual implementation is a little bit more complex than what I've shown here, but this will get you to kind of understand what's happening. It'll let you understand the limitations of the data type. Okay, so we got to keep track of true and false as well. So we're going to store 0 to mean true, and interestingly, we're going to store -1. 0 to mean false, and -1 to mean true. So in practice, and the question came up here, why doesn't it overflow when you do that? And the answer is VBA is going to try to guess at what you really mean. So in practice, anything that you refer to as a 0 will be false, and any other number will be true. So if you want to think of true being 1, that would serve you as well. So this is really strange to me, but VBA actually takes 2 bytes to store 0 and 1. And I think it's an efficiency thing where they're saying it's a little faster to do it this way. I don't know why, even though they're taking up a little bit more memory for it. So this is 0, because when we think about a 2-byte number, it starts counting at -32,768. And so the representation here is 32,768. So that is 0. And so that's going to be false. And then this is 1 less than 0, or -1, and that's true. So that's how it actually stores it. But the data type that we have is Boolean. It is a strange word. It's named after a guy named George Boole, who was an 18th century mathematician who spent his career like thinking about what we today call Boolean logic, but this idea of if you have true and false values, how can you manipulate them in interesting ways? You might have remembered in high school, pre-calculus or pre-algebra or geometry, where you had to do truth tables like true and true equals true, true or true, true and false, true or false. You have George Boole to thank for that. So, but the range here really is just true or false. Dates, kind of interesting. The way it stores a date is by saying we're going to keep track of a number, but instead of like adding it to a beginning number, we're going to add or subtract that from a beginning date. So it happens that the initial date is December 30th, 1899, which seems like such a strange initial date to me. I could go with January 1st, 1900, or even December 31st, 1899, but it happens to be this, December 30th, 1899. So if we've got the number 27,945 stored, we're going to add that on to the beginning date, add that many days to it, and we're going to come up with January 4th, 1976. Questions? So there is a data type called date. And if we put into it, if we put into it a number, let's put 0 into it and print that. I'm not quite sure what that's going to print. Let's find out. Yeah, without a decimal on here, it thinks I'm just, let's put in a 1, let's put a 2 in there. Yeah, so that's January 1st, 1900. So day number 1 is 1 day past the initial date, or December 31st, 1899. Put a -1 in there, it should be the 29th. Application defined error. I'm not quite sure why it won't let me put that value in there, but we'll skip that for now. So the next thing is it's a time. So what if we're going to add on to the initial date? We're add on to it 1 day, 1.5 days. then it's going to come in and say that's 12 noon. So maybe not quite 1.5. Let's put it at 1.4. And that's going to be 9:36 a.m. So dates have times as well. And it's just we're adding on, instead of just adding on a whole number, we're adding on a portion of a day. So we're adding on for the initial day, we're adding on 1 day and 4/10 of a day, which happens to be 9:36 a.m. Now, interesting thing about the date here is that you can assign it a string, just a set of characters, like 1/1, 1/10, 2022. And this is something that is mind-boggling to some people that come from other environments, because it's going to actually store that numerically, but it's so strange to say, listen, I've got a string, just a bunch of characters, and try to write that into this that has an underlying numeric value. And what happens here is VBA says, well, let me look at that string, that collection of characters, and can I make sense out of that as a string? And the answer is, in this case, yes. I'm not sure if it'll do this one. Here's another standard format. So the 10th month, the first day. The question is, can VBA understand that string? And the answer is, yeah, it figures that one out as well. I've got it. Yeah, that's the 10th month, first day, right, 10/1. So it's got kind of a lot of different formats that it could read and understand, but like even, let's try this one. JULY 4/19/22. It figures that one out as well. So anyway, that's the date type. And the date type and the time type, then, I'm sorry, it's still the date type, but it handles this fractional stuff to be able to say portion of a day gets me to a different location. Okay, so your range is from midnight, the year 100. Yeah, so you're going way below the 1899 starting date up to 9999. So basically from the year 100 to the year 10,000 is the range for date. What if you want to do something that's like BC? Got to keep, is it reasonable to keep track of things that are, that the date is BC? Yeah, you don't use a date type for that. You just have to kind of keep track of it separately. There's no kind of built-in type for handling dates earlier than the year 100. Okay. Tell me how you're feeling about the stuff we've covered so far. Just kind of show me on a scale of 0 to 5 fingers, how comfortable are you, what we've seen so far? 4, 2, 5, 5, 5. Thought that was a 0, but he was trying to decide just how comfortable he was. So, okay. So some of you are like, yeah, we've been here before. For some of you, it's brand new. You're going, wow, this is a lot to bite off. Okay, so the question is, how do we represent like a name? How do we do characters, right? Because ultimately, everything has to go down to be 1s and 0s. So the idea is we're going to say, we're going to assign each character to a particular value. And there's going to be a table that VBA uses in its little VBA brain to keep track of and map between the number that's stored and the character that you really want to see. And so it happens that 64 is capital A. And so if I store 64 and I know that the type, the VBA interpreter knows that this is a type of type string, then it's to say, take out that 64 and then map it using this, let's see, and map it using a table we'll see here in just a second. But there then is how it stores, and I'm going to turn this on its side here. And so that's the same picture, just turned on its side, A at the top. If I had a longer thing to show, then it would be each set of 8 bytes gives me 1 character. So this one here is number 65, that's A, capital A. 100, right? We're representing out 100 here in the bits. That's gets mapped to D. 97 is lowercase a. The important thing to realize is that it's not just letters, but it's all kinds of characters have their own maps. So comma has its map, 44. A space is mapped as a character, that's 32. That's the lowest one that you can actually print out, although there are characters that go lower than that. So again, we would just write this Let me do another one here since we're going on to strings. Dim x variables 2, dim x as a string. So I'm going to be kind of instructive as well right here. So I'll go ahead and run this. I'm writing the same thing into it, but now because the data type is string, it's going to go, oh, I'm not trying to convert that collection of characters into some number. I'm just storing that collection of characters. So instead of giving me back out the date, this should just give me that set of characters right back. Variables 2. And so in this case, it says, I'm going to store that collection of variables, and it says lowercase j will be the first one, whatever number that is, and it'll just line it up. Question mark? Any questions? The table that it uses to map between the numeric representation and the character representation is called the ASCII table. Have you heard of it? ASCII, maybe a third of us have. Stands for American Standard Code for Information Exchange. I put that on the slide because I could never remember, and students sometimes ask, what does it stand for? It stands for that. So we can see over here, here's 65, and then everyone else then has some specific value. So we've got characters from 0 to 127 because it's 1 byte, and then we can do lots more characters than this, but for the string type, this is the part that's going to be really reliable for us. Once we get into other fancier characters like characters beyond this, it's not, we can actually store a character that's represented as something other than these. But have you ever been to a web page and you look at it and you go, wow, I think that's supposed to be an apostrophe, but it's just showing as a question mark, or it's showing as some other character. Have you seen that? Just say that you've seen it. Yeah. So you go to this page and there's something wrong about the encoding on the page. What that means is the character that was rendered was something above 127, and the mappings between those numbers and the characters they actually represent is different in different operating systems. And so it might map one way for Unix where it came from, and it's mapping differently on your Windows machine. But in this range, 0 to 127, it's standard. Let's see. I wonder if we can do this. One of these says bell. Can you see it? 7, audible bell. I'm not entirely sure. So we can, I could print here character number 65. So there's a function built into VBA that does that mapping from the ASCII table. And if I print 7, now it doesn't actually do a sound. It just says, I'm not quite sure how to print that. And so it gives me some symbol that says, I don't know how to print that. All right. Now, this introduces us into something now new. All the data types that we've talked about so far have been fixed size variables. So when I declare a variable of type long, I'm allocating 8 bytes of memory, and that variable is going to stay in that same place. And if I try to put something that won't fit, it'll either get rounded or it will get an overflow. Strings, and this is called the string type, but the string type is a variable sized variable, or maybe a dynamic sized variable. And what that means is it's going to take 1 byte of memory for every character in it, but it also has to know how long it is, how many characters there are. So here to actually store John Adams, we're going to use 1 byte for every character, but every string has 4 bytes of overhead that these first 4 bytes are telling us how many characters are there. And so you can see these last 3 bytes are all zeros. So it's just 8 plus 2 plus 1. So that's this whole green part here says, hey, there's 11 characters here. And so that's how many characters we are here. So remember that the variable itself is a single address, right? The variable is a name to a starting point in memory. And so this variable has to say, I'm starting at this location in memory. The first 4 bytes tell me how many more bytes to read to be able to find out what the whole string is. As a result, because a string can actually change how much memory is used every time it gets written, there's something interesting we'll see here in just a second. So the data type is string. It's 4 bytes plus the number of characters. Yeah, okay. So let's take a look at this. So I'm going to say dim name as string, and the operating system is going to say, great, here is some, here's your starting point. It gives me this, this starting point right here. And then these 4 bytes are all set to be, or these 4 bytes or these 32 bits are all zeroed out, which says this string has no characters. How much memory does it take to store a string with no characters? It takes 4 bytes. So I got the memory allocated there, 4 bytes, and it says there's nothing here. It seems like a waste. It takes 4 bytes to say there's nothing here, but that's what it does. So now let's say I want to put something into it. Oh, there's the 4 bytes. I'm going to say I want to put Adams John into that. So now I'm going to need the next 11 bytes, but what's the problem? I've got 1 more byte here, but what am I showing with this gray right here? That's allocated to somewhere, that belongs to somebody else. What's going to happen if I try to just put out, I can get the A in here, but if I try to get that lowercase d, it's going to run right over the top of something. And so what happens, what VBA does is every time you change the value in a string variable, it says, oh, we better ask for a different location in memory. It's going to say, I'm trying to put in John Adams here. It's going to say, oh, we need 11 plus 4 bytes. It will ask the operating system, I need these 15 bytes. And the operating system say, yeah, here you go. Here's where it is. And then it will allocate that there. And if you wanted, something fun to do for a little exercise, you could actually go and see that I took the time in this slide to actually make that say John Adams in 1s and 0s. Yeah, you may have more important things to do. Apparently, I didn't have more important things to do at the time when I was making this slide. So, but the interesting thing here, and this is not true in all languages, but in VBA, every time you put a new value into a string, it moves that string to a different location in memory, even if it would fit where it was. So that has some performance implications if you're manipulating large strings. Go ahead. Okay, so the question is, well, how does it find the next place where it's allowed to go? And the answer is the operating system does that. So VBA says, operating system, I need 15 bytes. And the operating system says, great, here they are. They start at this address and you've got 15 bytes. Right? If there was a problem with the VBA interpreter and it tried to read 16 bytes, it would be the job of the operating system to like terminate it and say, you're doing something malicious, and it would just kill it from happening. So the operating system says, here's where you start. It keeps track of the fact that that's been given to the VBA interpreter or given to Excel. And then it makes sure that whoever's accessing that is who is allowed to access it. Okay, next data type is, so that's string. What are you gonna know about string? You can put a whole lot of text into a string variable. You can actually put 4 gigabytes of text into a single string variable. Yeah, that's a lot. But it's going to take however many characters you have, that's how many bytes it's going to take, plus 4 to keep track of how long it is. Now, we've got another data type here that's complex. So far, like all the numerics and the strings, everything we talked about so far is what's referred to as a primitive data type, which means it's storing a value. And you might think of a string as a bunch of different values, but remember, that's getting mapped down to a single numeric value that it's translating back into all these characters. Object data types allow us to say, I've got one variable that has multiple properties to it. So this variable is going to have, like, you almost think of it as a sub-variable built into it. That's got like an address variable that's part of it, a formula variable that's part of it, and kind of these other things. So we're going to get familiar with objects. It's a lot to bite off on our first day. So at this point, we'll just kind of look at a couple of things here. So when we declare a variable of type object, like here, dim RNG as object, then we're getting some location in memory, and again, keeping track of how many bytes is allocated. Now, what we're going to do here, and this is the main use that we have for object variables in VBA, is I'm going to say, listen, I want to attach that variable that I just created onto an existing other variable. An existing other object. Remember that all my ranges are objects. And so I'm going to say, listen, I want RNG to refer to range A1. So now in my code, I can say RNG dot, and that's going to say, oh, you mean range A1. And then anything I could say after a particular range, I could now say after this variable. So this allows me, we have to use this keyword set. We'll talk about more of that later in class. But this is going to say, we're now making this new name and binding it onto an existing object. So, and you'll see why this can become handy. I just want you to realize that there is a variable type that's called object, and it just allows us to bind variables onto other existing objects, create objects of our own, is beyond the scope of this class. The last data type we're going to cover is called variant. So variant is, it's like the problem child of variables. Variant will behave the way you treat it. And this is Microsoft's attempt to say, listen, we want to be as friendly as we can. You treat this like a date, it'll behave like a date. You treat it like a floating point number, it'll behave like a floating point number. You treat it like a string, it'll behave like a string. You treat it like an object, it'll behave like an object. The price for that flexibility is 22 bytes of overhead. So in this case, 22 bytes, it will then kind of, when I try to do the same thing I did with the object variable, it'll go, all right, the 22 bytes lets me know I'm keeping track of the fact that it's an object in there. I'll get 8 bytes for the object, and then I can use it the same way that we had it before. I could say set range equal to that range, it'll bind on to that object. Or I could just say range equals that particular reference to that and the value. Now here, I'm not trying to bind onto the object. I just want to read the value out of a property of the object, and I can treat that this way, and it said, great, we'll behave that way. So when I was first making this class, these many decades ago, I thought, well, maybe we'll just only tell them about the type variant, and then just make everything variant. It's going to cost you an extra 22 bytes every time you make a variable. Big deal. You've got billions of these that you're not even using. And so I first started teaching this class just saying, just make everything variant. But here's the problem, is that in that process where it's looking at how you're treating it, it's got to try to guess at what you want it to do. And it guesses in a very systematic way, but it's sometimes very counterintuitive to what you would expect it to do. And so I found that my students were spending way longer trying to debug their code because you don't get the kind of behavior you expect. So there are some limited number of times when variant is like the right one to use, but other than that, you should probably avoid it and use the data type that makes most sense. And I'll show you a couple of reasons why during the class why you would use variant. Okay, here's what you should memorize for the test. This is the first year I put this slide in. So when you're preparing for the midterm, this slide will be helpful to you. Yeah, it's a new method of note taking. I'm seeing all kinds of pictures out here. Remember, you have a link to this in the blog. So, but hey, take the picture. Okay, we got like 5 minutes left. We could do some other demonstrations. If you could handle any questions about variables. Oh, there is one thing I at least want to tell you that we're not going to cover it. So what we're scheduled to cover for today is variables and constants. Let's take a constant real quick. We'll look at a constant. So a constant is exactly the same as a variable with one small difference. I'm going to say const instead of dim to declare it. Pi, and then I'm going to assign its value right here where it's declared. Equals 3.14159227. This is still a location in memory that's going to get its value. If I want to, I can give it a type as well as single. And let me go ahead and print, instead of X, I'm going to print pi. The difference is once I've set it, I can't change it. If I try to change that in code, then the interpreter says, no, that's P1. That's saying, hey, that's not defined. But PI would give me a different error message. it would say assignment to constant not permitted. So if you're saying, listen, I've got a value here, but I don't want to change by accident. You know, pi has been that number for like 300 years, 400 years, hasn't changed since that. It's probably not going to change while my program's running. So, we use it for things, it's probably best to use it for things that never change. Some books will say things that aren't going to change while the program's running. You don't want to have to come in and change your code, like a tax rate or something. Some of the bad examples are like use a constant for tax rate. Don't. Put your tax rate somewhere that can be updated easily. But go ahead, question. Oh, good question. So what if I did this? What if I just did dim x without giving it a type? And if I do that, that is equivalent to saying as variant. So yeah, if you just say, I'll just declare the variable that way, it's going to make it a variant type. Now, if I say dim pi or const pi and I don't give it a data type, it's not going to be variant. Because variant, all that overhead for variant is, it has to keep track of it. This might change one way or another. This isn't going to change. So it's going to actually, it's going to pick a data type and it's going to use it for this. So let's see if I can stop. I can ask for the length of pi. Length of pi. Length of x. So I guess I can't ask for the length of a constant, but it has picked a data type and it's using that. And because it doesn't change, it doesn't have the kind of overhead that variables have involved. Now, the one thing that we're not covering today is chapter 7. So operators and expressions. So I'm going to just kind of expect you to get some familiarity with chapter 7. We're going to use these things without really defining them. But if you want to be, you know, kind of like totally up to speed for the next time we get together, take a look over chapter 7. I'm assuming that you've got that, even though we haven't covered it in class. Last question. Yeah, there's all kinds of quizzes in My Educator. That's because, well, the guy, you know, put quizzes in the book. I don't really care for the quizzes. Like multiple choice to like learning programming language, I think is worthless. So I will not assign those to you. All right, thanks for coming. Class dismissed.